Hey everybody, this is Larry. This is April 2nd here in New York. We did the day 3. I know it's always off by 1 or something. It's really weird. But basically this is the bonus premium challenge that I set for myself on just random days, to be honest. But yeah, let's take a look on some of these. And yeah, today we have a hard one. We haven't done a random premium hard problem in a while, so I'm excited for that. It is a hard one, right? It is hard, but sometimes I can't tell if these are premiums because I'm on the old UI and the old UI doesn't have premium stuff, or like the tag or whatever. Doesn't matter. Hit the like button, hit the subscribe button, join me on Discord, check out my handstand video if you want. Let me know in the comments, and yeah. Let me drink the water and then we'll start. Today's problem is 774. Minimum max distance to gas station. You're given an integer array stations that represent the positions of the gas station on the x-axis. You are also given an integer k. You should add k new gas stations. You can add the stations anywhere on the x-axis and not necessarily on an integer position. Let penalty be the maximum distance between adjacent gas stations after adding the k new stations. Return the smallest possible penalty. Answers within 10 to 6 of the answer. How many are we supposed to add? Oh, you're supposed to add k stations. Okay. Penalty is the maximum distance between adjacent gas stations after adding k new stations. Okay. So basically here the answer is going to be, what is this, 20 or 19 or something? You add something in between, and then this is 14, right? Okay. I'm trying to think. Okay. I think this is a fun problem, kind of. I mean, the two trains of thoughts that I had in the beginning, right? The more quote unquote, I mean, the first obvious thing is that, okay, we have k stations, we don't add in between the biggest number. I think in greedy that makes sense. But then now, what do you do if you want to add the second station, right? Now I was thinking initially just treat the new thing as a new station, like the new station is in between, and then just kind of, do that. But you don't want to do it that way, right? Because for example, let's say, and it doesn't really matter, you have say 1 and 100, you only have 2 stations and you're trying to add 1. And the first one is going to be 150, 100, which is obvious, right? But then now the second one is not going to be 125, 50, 100 because then now the max distance is 50. What you actually want is quote unquote go back, but you can just do the math easily, where you go 33 and a third, and then 66 and a sixth, and then now the difference of course is now 1/3, right? Or 33 or whatever it is, right? 33 and a third. So then the idea here then now is that it's going to still be a heap, which is that we take the thing with the most expensive thing, but we, instead of keep on subdividing it, we just change the denominator. Sorry, yeah, the denominator. Well, yeah, the denominator, right? So then here the distance is 99, I guess, and instead of divided by 2, instead of dividing by 2, you now divide it by 3, right? So then that's how you set up the heap, and once you do that, then the max is going to be, will be good. So then now we want a max heap, right? So heap, we'll set up a max heap, which is always a little bit awkward to write in Python because Python is specific. Starts at min heap, but you can't pass in a key, as far as I know. If anyone reading or watching this, knows how to do it in an easy way, let me know in the comments. But the way that I do max heap is that I just change I multiply it by -1 eccentric, so I change the signs of it. But yeah, so then now for xy in SIP of stations, basically for every 2 adjacent stations, we want to set up y minus x and then 1, right? Something like this. But these are not the key, that's the distance, that's the numerator, or denominator, sorry. But we actually want, we probably want a fraction, to be honest. but maybe this will be good enough for now. I mean, if we need more precision because we messed up during precision, we will figure that out. But yeah, but basically that's the cost, because now this means that if we update this, this is the number that goes down. And because we only care about the maximum, we always want to make changes to the maximum, because if we change any other station or distance, it doesn't change the maximum, right? So yeah, so that's basically the idea. Oh yeah, and we have to change this to negative, as we said, because we want to make this a max heap, right? Oh, order of operation, I am a bad person. Right? And then now we want to heapify, and then yeah, that and then we just go, right? So ooh, K is small. I do want, I mean, the way that I'm going to do it now is that we're going to do it for every K. I do wonder if it's fast enough, to be honest. Because 10 to the 6 is kind of huge. But 10 to the 6 times heap of, or like log 2000 is actually pretty slow. Let me rethink this. I mean, the way that we do it will work, but can we do it faster? Right? Because for now, all right, let's not prematurely optimize. I think it's, I don't know, it may be actually too slow, to be honest, but it's on the borderline of too slow, so I'm going to give it a little bit of YOLO, I'm not going to lie. And if it doesn't work, then we'll optimize. Let's not prematurely optimize for this one, even though it's a little bit on the border and I'm mindful about it. We'll see. Yeah. Oops. Right, so we have the score, which doesn't matter. We don't care about the score. We have the delta, and we have the, we'll just call it numerator and denominator. So num and dom, right? And then basically, we now just push it back with the same thing, right? A negative num, well, we increase the denominator. And then, yeah, the numerator denominator is the same. Or, well, the denominator got updated, but otherwise it's the same. And then now we can return. So then now, after all the k iterations, the number that's on top will be the max delta, right? So then now we can just do, right? So then now we care about the score. We don't care about the other thing of, well, we could even just look at h of 0, maybe. Maybe that's a little bit more precise. And then we can return negative score. I think this works. Maybe. Oh, well, maybe some syntax things. Python heap is always very weird to use because of the syntax. Because I expect, you know, in the sense that, like, I'm always thinking about an OOP, so when I think about parameters, I don't have to think, but then, you know. Okay, so yeah, okay, so this works. But k is small, so it's tricky. But let's give it YOLO and see if it times out. Or maybe we get a wrong answer and it's moot, right? But I think it'll probably time out, to be honest. Because 10 to the 6 is actually a little bit too high. Yeah. And this is sorted already, right? Just in case I messed that up. I think I remember reading it sorted, but. Okay, I mean, this is kind of what we expected, right? Ooh. There's a, I don't know, maybe this is old UI stuff, because I feel like in new UI I could just copy it, but. Okay, so if I just ran that number, so it's a sum of submission thing. Because I guess we have too many test cases. Doesn't it tell you? I thought it used to tell you. Even it's 50. So we're close, but not enough. Okay. So then we have to do an optimization, and it may not. This may be the tricky part, to be frank. It's about figuring out the denominator. Can we speed up? Well, the two train of thoughts that I'm thinking right now, two different possible tracks, and I don't know the answer for this one, just to be clear. Right, one is that we try to figure out how to speed this idea up by, you know, maybe skipping ahead or something like this if k is big. And then the other is that just, you know, having a different idea altogether, right? I don't know. I don't have an idea yet. At least nothing immediate, because if I did, then I would just, you know. Only 2,000 stations, right? I think one thing that I'm trying to think is whether we need or position, right? Like a number divided by 2,000. So 2,000 stations in the worst case, like a number over 2,000, 2001 doesn't change the answer, maybe? I don't know. That maybe that's still not precise enough though. I mean, okay, I guess there is another answer, which is kind of funky. I mean, I mean, the other way to do it is by binary search, is what I was going to say to do. Maybe I should have done it that way, to be honest. The idea here with binary search is that, well, if you're binary searching for the penalty, for the answer, right, then now you know exactly how many k to use, and that's it, right? Okay, fine. How do I do this? So, or not how do I do this? I'm just trying to figure out what is the what's the best way, like the bounds. Basically, I'm doing binary search. I want to figure out what this right part is. What's a reasonable bound? I guess like just the max of station is fine, right? Well, I guess that's in this one it's already sorted, so it should be just the last number. This is way way upper bound, but that's fine, right? And the good thing here is that this is yeah, this should be fine then, right? Because basically, actually this is set up a little bit whatever yucky. What I actually like to do is that I like to kind of just do a loop, maybe say back of the envelope 100 times, and that's kind of back calculated by that 100 times n, which is 2,000 will be 200. Oh, that's more than fine. Let's just say 200, right? For some reason I was thinking about 1,000 and I was like 2 million, but no, then yeah, now here's 400,000, right? It's 200 by 2,000, and the reason why this is going to be fine is instead of using this, because, well, one is that because of precision issues, this may never terminate if you're not careful. That's one. But if you do 2,000 times, you just ran out of bits, right? So it will definitely be within 10 to the negative 6. And then, yeah, so then basically the idea is that, okay, if good of mid, and what does good mean? Good is basically, can we get the penalty to target or less, right? So yeah, so if this is good, then we want to try a smaller number. So we can set right to mid, else left is equal to mid. And then at the end, we can return, well, left is equal to right, it converges, so left, return left is fine. You can even return mid, probably, it doesn't really matter. Though I always write left for consistency purposes in case where it does. Like this particular one, not really, but yeah. Okay. Yeah. And then now we do a thing, right? So for XY in SIP of stations, and this is probably like still not the cleanest way to write it. Okay, fine. Let's just write it a little bit cleaner. I'm like, yeah, okay, fine. Right. Oops. Range of n, or just n, but I like to do the -1. So delta is equal to stations of I minus stations of I minus 1, right? And then basically we have used is equal to 0. And the idea of used is that, okay, let's see, delta over some number has to be less than or equal to target, right? So we want that, right? And for this purpose, we can actually set it to equal, kind of. So that means that we're multiplying number on both sides. Is that good enough? No, because we know target, right? So that means that it's delta less than or delta by target. And all these are positive numbers, so it should be okay, right? So that means that delta over target is equal to number that we care about, except for number has to be, it has to be an integer, right? So then looking at the original equation, which is the number is equal to target. If this is an integer, if it is too low, is going to be if it's too low, then this is going to be bigger than it, right? So you want it a little bit higher. So that means that we want the ceiling of this, right? Okay, so then now used is equal to the ceiling of delta over target, right? And then we can return used is less than or equal to k. Except for I'm going to rewrite this to be to use only integers, right? So the way to do that is just change this to plus target minus 1 over target. That's how you do ceil. And yeah, and you could even actually early terminate if you want, which is that if use is greater than k, return false, just to make it run a little bit faster. Okay, well, surprisingly, this one came out a little bit better, but the other one's not so much. Why is that? Well. Do I have a typo somewhere? Or is that it? Well, this is pretty correct, I think. Though maybe I should double check. If mid is good, then we want to try a smaller penalty. No, that's good. So, I mean, this is the only thing that should be this, right? All right, let's just print that. All right, let's comment this out so that we can print target used, right? So 5, we use, use this. Oh, because, I messed up. This formula only makes sense if target is, if target is not a fraction. I am being dumb. So yeah, so actually, okay, let's just change this back to what we had. That's a brain fart situation, to be honest. My fault. I also want to make sure that target is not 0, but I don't think it can be, but maybe I'm wrong. All right, let's try again. Why is that? Let's print it again. I'm having some like minor issues, hopefully, but is it ceil? Ceil is the number, right? Because we want to up. Now that makes sense. So 5 requires 9 seems wrong. And also you can see that this is not monotonically increasing, which means that something's a bit funky, right? So 5. So you have 1. Oh, because delta is 1 and target is 5. Do we want ceil? I think it's either that or I'm missing an edge case and thinking about this. All right. Well, let's just say that if delta is already smaller than target, we continue. Does that fix things? But it feels like a weird way of putting it, that's why. Okay, so 5, we use 0, so that means this is true, so try something smaller, 2.5, okay. 6.25, we have 18, so something, my formula is a little bit off, maybe. All right, let's try again, right? So we have delta over number? Is that true? Maybe I just messed this up. Maybe I just had the formula wrong. I kind of sped through that one. Okay, so we have the delta. We want to divide it by some number so that it is less than or equal to target. Right? Oh, I see. I see. Okay, I think I figured it out. Maybe it's this minus 1. The reason is well, let me run it real quick. Yeah, okay. I'm just being dumb. Yeah. Okay, that's what I thought. The reason why there's a negative -1 is because this formula tells you how many parts you need, how many parts are required, right? Because for example, let's say you have 84 and 98, that means that in between there's 14, but if that means that it requires one part, but one part means that you already have one part, not one used to add in a new station. So that's why we have to subtract that one, and then once we did that, it looks okay. Yeah. And you can also see the running time is much faster as well than the other thing. And we can even now do this to, I don't know if that changed anything. I wasn't paying attention. But yeah, cool. Apparently there are even faster solutions. Maybe there's a more analytical way. It's either that or this max is too much, but I mean we can also actually this could have been just the max of whatever, but it doesn't actually change anything because my loop is 200. It may be that the 200 loop is a little bit too much. I know that's too much because I was making sure that is correction. Like if we change to 100, would it be 100? It would probably still be good enough, but I didn't want to risk it. Like I knew it would be fast enough, right? So yeah, though it's still slow, huh? Maybe I'll take a look at the solution. All right, let's go over this complexity real quick. I mean, this is binary search. This only loops 100 times, but you could also represent it in the odd number. You could represent this in the as a function of the number of bits. So it's gonna be like O of B or something like that, because it's just bits of position, right? And then here is O of N, so it's gonna be O of B times N or something like this. Time and O of one space. We don't really do anything. DP. Oh, I mean, I didn't even think about using. I mean, there's an obvious DP, but yeah, brute force also time limited. Heap is time limited. I thought heap may be a little bit fast enough, to be honest, but yeah, binary search accepted. Okay, well, thanks for wasting my time with the other three ones. But I don't know why that is. Why is it so slow relative to the other ones? Because usually, I mean, I guess you don't even need 100, but yeah, I mean, yeah, okay. So maybe you can do some binary search and early termination. I'm too lazy to kind of. We could binary search for the answer for this, but it's fine. I don't worry that much about it. It is binary search. The reason why I do this is just for convergence purposes and not really needing to care. But yeah, but you can actually do the math, right? 10 to the 8, right? The delta is 10 to the 8, 10 to 16, so it's 10 to the 14 change, and 10 to the 14 is what? 2 to the 30 is 10 to the 9, so 10 to the 14 is what, like 10 to 2 to the 45? I guess this is roughly right? So I don't know if we're gonna make it off by that much. But yeah, alright, that's all I have for this one. Let me know what you think. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think. I'll see y'all later and take care. Bye bye.